Okay, so let's maybe try a different example. So we have gone through an a equals 1 example, and a is larger than 1, and now let's try this example. It looks really big already. It looks kind of intimidating, but when you see that, you want to make it less intimidating. There are 3 terms. It's a trinomial. Notice that there are n2 in all of them. The highest, greatest common factor is n2, and I also need a coefficient. It's gonna be a value of not 2 but 4 because that's the highest. How do I know that? They're all even numbers, but they're also all divisible by 4. When we have a GCF, what you're gonna do is you're gonna divide all 3 terms by 4n squared. When we do that, we have 4n squared bracket 28 divided by 4 is 7. That's gonna be n squared, because when you divide terms and they have the same base, you're gonna subtract the exponent by exponent law. Next we have 16 divided by 4, which is 4. N3 minus the 2 on the exponent is n. 80 divided by 4 is 20, but it's gonna be a minus 20. Are we done? No. We have a trinomial, so we want to be able to factor this. So again, I'm going to try to use the method I did above there. I'm going to write down the factors of 1 and 7. There's only really 1 and 7. It's a longer list for the 20 and 1. So there's 1 and 20, there's 2 and 10. I'm just writing it backwards as well. 4 and 5, 5 and 4. Notice that I do go in order, 1 and 20, and I have 1 and 20, 2 and 10, and then 4 and 5, because if I do it this way, I'm going to make sure I'm not leaving out any factors. Unlike the previous question, for this question I'm noticing that I have to multiply to a negative while adding to a positive. This means that I need to multiply, so I have one negative, so that one of these numbers are gonna have a negative. I'm not sure where, but we have to think through that. So somehow I have to add to a 4, meaning I am probably gonna not involve which factors. Probably not these, because that's gonna be a 20 and something, but I'm getting a really small number. So kind of process of elimination, that probably won't work, because like 7 times 1 is 7, 20 times 1 is 20. I can't add it or subtract to get 4. Same idea for these ones. 7 times 20, that's 140. That's way overhead. So let's go to the second part. So we have 7 and 2 and 1 and 10. That's the crisscross check. So wait a second, we have 7 and 2, so 7 and 2 and 10 and 1. So I might have been lucky that I listed the number kind of correctly. And now I have to determine, where do I put the negative? Where do I put the negative? Because I want a positive 4 and not a negative 4. So that means I want the minus to be there, so that this equals 14 minus 10 and equals 4, because this is what I actually wanted. I wanted the 4 for the middle number. So I'm going to circle this and circle this. Meanwhile, I want to put a negative there, right? So this is kind of in my way. So I just want to show you what I was thinking in my head. And so I'm going to list it. Remember, when I'm listing it, I'm writing it horizontally. And so I write 4n squared. I'm going to write not just 1, but I'm going to write 1n, which is really n, plus 2, 7n minus 10. The question originally was asking to factor this, not solve. So because it's at the factor, you're going to stop here. And I can't really factor anything else. This is an odd exponent. There's not really anything else for me to do, so I stop here.